My duty here is to is to take you through some simple mathematics of probability. I don't know whether some of us have ever heard of that word, but I guess since we are in senior 5, we covered some trigonometry, some probability in our ordinary level, especially I think around senior 3. So do we still remember what probability means?
Yes, teacher.
Okay, Becky, you can tell us what probability is. Becky, unmute and talk.
Okay, teacher, I've forgotten.
You've forgotten. Okay, and anyone else who has an idea of what probability is? Can just unmute and speak. Oh, seems most of us forgot. Okay. If we begin with an assumption, maybe we are planning to go and visit a friend or go to the market, depending on what you wanted to do. And then before you leave home, it starts raining. What do you think will happen to your planned journey? Someone with Galaxy, you can tell us your name and then you tell us what you have for us.
You can either go or you may not go.
Okay, you can either go or you may not go. That is good. Yes, you are adding.
Because if the rain keeps on raining, then you may not go. But if it stops, then you can go.
If it stops, then you can go. Now, so there we have two options. For this. So there we have two options that we can do to go or not to go. Any other? Anyone with a different approach? Okay, then there are some of us who like watching soccer. If a team is playing against another team, what do you expect? Please, I need answers. I need us to be lively and then we contribute. That is when we are going to learn better.
Teacher.
Yes.
One team will win while the other will lose, or there will be a draw.
Okay. So there we have three options. We can either win, we can either lose, or we can draw. Now with the probability, we look at it's basically a branch of mathematics that deals with the chances of an event occurring or not occurring. Maybe if we could go to some bit of Google, we would understand better what probability is. And then if you do some good research, you'll find out what probability is. But we are going to be dealing with the predictions of whether an event is going to occur or whether it will not occur. So basically that is what we look at in probability. So we are going to do a further research in our free time to find out what probability is. So let me focus on what I'd prepared today. Had some of us started on probability in our in our schools? Had we begun on probability?
No, teacher.
Okay. Now, here we are going to look at, basically I've explained what we do in probability. We are going to basically be looking at predictions of whether an event is to occur or not to occur. So then in still that probability, like we have seen, we shall look at terms like the sample space. So the sample space is the possible outcomes that that an event, that we get after an experiment. So we are going to have a sample of some of them. So we are going to begin by looking at the sample space. So a sample space, we are saying this is a set of all possible outcomes. And we are saying each possible outcome is called a sample point. So for example, if we toss a die, how many of us know what a die looks like? A die, anyone who knows?
Teacher, I know.
Okay, how many sides does it have?
6 sides.
6 sides. So when we toss that die, we expect to get numbers from 1 up to 6. So that will be our sample space. And we are saying each of that, so like we have these numbers here, 1 to 6, each of those numbers. So this, if we throw, we can expect to get a 1. We can have a side showing 1. We can have a side showing 2. We can have a side that shows a 3 up to 6. So this set of all the possible outcomes, the expectations that we get, that we expect to get, we call it a sample space. And then we are saying each item or each possible outcome of the sample space is called the sample point. So we can proceed. So if we look at another example, if we are throwing a coin, so how many sides does a coin have?
2.
2 sides. So when we toss it or when we throw it, we expect that it is either going to show on top a head or a tail. So the head and the tail is a sample space. Then inside each of these points, we say that sample points, a subset of a sample space is called an event. For example, if we look at when we toss a die, we expect to get numbers 1 up to 6. But then if our interest is getting, for example, even faces showing even numbers. So now those faces that show even numbers, we call them, it's now our event because it is that part of the sample space that we are interested in. Have we understood what an event is?
Yes, teacher.
Yes, teacher.
Okay, just in case you have any question, just forward it in the chat. I will be able to see. And then we are saying the probability of an event is given by, so we count the number of events, and then we divide it by the number of the sample space. So for example, if our interest here was to get even numbers, so we have 2, we have 4, and we have 6. So how many are they? How many even numbers do we have in our set?
3.
3. And what is the number of the sample space?
6.
6. So we would say that the probability of getting an even number, which we can say E, is equal to number of S, number of events, which is 3. We divide it by number of the sample space, which is
6.
And then our probability would be
A half.
a half. Okay. Then it would be all around to do it. The question can be twisted. They can ask for prime numbers. They can ask for odd numbers and the rest. But the idea is just we get the number of events. We divide it by the number of the sample space. So that will be it. So any questions on this slide? Any questions? Okay, I think we can proceed. Okay, I talked about that. That is the abbreviation. Probability of E is equal to number of E divided by number of the sample space. So we are saying probability of an event ranges between 0 and 1. So why it happens like that? So we began with the, like, for example, if it rains, we expect two situations to happen. We can either go to work, to market, to do shopping. So it's 1. We can go or we cannot go. So because there are 2 possible outcomes, so the probability of going is going to be 1 out of 2. And the probability of not going is also going to be 1 out of 2. So if we do our simple mathematics here and we add a half plus a half, it gives us, what does a half plus a half give us?
1.
1. So when we add up the probability values for whatever probability topics we are going to cover, they should be able to give us a 1. So that is why we are saying the range is between 0 and 1. If you're doing a probability number and you get negatives, that means there is a problem with the working. If you get a number above 1, that still means there is a problem with the working. So all the values must range between 0 and 1. So we proceed. When we go in our intervals, that is how we abbreviate it. That 0 is less or equal to P, less or equal to 1. So where the P is standing for probability, and then the ranges are 0 and 1. Okay, we proceed. Then we are going to see how we generate a sample space. We have said the sample space is the set of all possible outcomes after we have carried out an experiment. So we basically have 3 methods. We can use a probability tree diagram. I think we looked at some in O level. A probability tree diagram, like the word says tree. You know, a tree has branches, isn't it so? Hello.
Yes,
Yes.
teacher.
Yes, teacher.
So a tree has branches. True or false?
True.
True.
Yes, so we are going to apply that knowledge in mathematics. So specifically here in probability. Then our second method, we're also going to use a table of outcomes. So outcomes, we are going to see how to still handle it. Then we are also going to see how we use the permutations to generate or to get probability or the sample space. So let us begin with the probability tree diagram. Now, assuming we have to toss a coin 2 times, how do you think we are going to generate our sample space? We are interested in tossing a coin 3 times. How shall we get the sample space? Okay, so we are going to first begin with a tree, okay, which has the 2 branches. So our tree is going to bigger. So those are the 2 branches. We have tossed our coin. So what do we expect when we toss a coin? What do we expect to get?
Head or a tail?
Head or tail. So on the upper part here, we are going to write a head. And on the second lower part, we write the tail. So if you can take note, I'm writing my letters above the lines. Okay? So that is
Yes, teacher.
what you should as well do when it comes to presenting the work.
Excuse me, teacher.
Yes, please.
Why not below?
Below, we are going to be writing probability values later.
Okay.
Okay? Yes.
Okay.
Yeah, but I think we can still do it. So what is the what is the probability of getting a head when we toss a coin? A half.
Half.
So we write our a half here, and also a half. Much as to this time we are not interested in getting the probabilities. Then, if we had tossed a coin and it showed a head, and we pick that same coin, okay? We toss the coin, it gives us a head. We pick it and we toss it again. What do we expect? What do we expect?
Pardon, teacher.
Do we have some coins around?
Yes, teacher.
Yes, teacher.
Okay, now get that coin, toss it. And when you toss it, you tell us what you send in the chat what it gives you. I'm only going to pick a few people to tell us the answer, what they have. Okay, someone here has sent the answer. Galaxy has got a head. Thank you. Galaxy, please tell us your name so that we don't continue calling you Galaxy A32.
Swabra.
Swabla. Okay. Any other? Okay, Chantel and Shailene have a tail. Now, let me begin with the Becky also has a tail. Okay, so now let me pick the one who got a head. So pick the coin and again toss it. And we see what comes. Okay, now it has a tail. Okay, those who got Chantel and Becky, pick your coin and throw it again and tell Andy, then you forward us the answers, what it will show. Okay, Becky says it has a head. I'm waiting for Chantel to tell us what they have. Okay, for them, they have got a tail. So the lower part is complete because we had two people doing this, the work. So here, this got a tail. Here there was a head and a tail. So specifically, this one here has to be a head. If we had someone tossing, we would get that answer. Now, remember our focus here was to generate a sample space. So what do we have at the end here? So we are going to follow our lines, okay? So we began with a head, followed by another head. So what do we have at the end? We just combine them, okay? So here we say head and head. Have we understood?
Yes, teacher.
Yes, then
Yes.
we are going to follow again. Let me pick different color. So we had the head first, and then later we got a tail. So what are we going to write?
Head and tail.
Head and tail. Then we go back to this lower part. We got a tail, and then after we got a head. So what do we expect?
Tail and a head.
Tail and head. Then lastly,
Tail.
tail. Then after doing this, now we write our sample space. So we are going to write head, 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 tail, tail, head, and tail, tail. So that will be the possible outcomes when we toss a coin 2 times. We're going to have head, 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 tail, then tail, head, and then lastly tail, tail. So this will now be our sample. space. Any questions before we proceed?
No, teacher. No.
Okay, okay. Okay, so this is just some little explanation. We're saying tree diagrams can be used to obtain the possible outcomes of an experiment carried out a number of times. So there we have an example. A coin is thrown twice. List down the possible outcomes and hence find the probability of obtaining one head and two heads. So basically, this is what we have just done. So we stopped on this. Our sample space is head, 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 tail, tail, head, and tail, tail. So what is the number of the sample space? Number of sample space?
4.
4.
Oh,
4.
So now, probability of obtaining, if we are interested in getting one head, so we're going to go into our sample space. We pick out where we are getting one head in the two tosses. So, and that is going to be where we have head, head, no, head, tail, and then tail, head. And then we write them here. So what will be their number?
2.
2. Then we shall say our probability
The half.
is a
A half,
half.
teacher.
Okay. So probability of one head is 2/4, which gives us a half. Then probability of getting two heads. So we have only a head, head. So that is 1. So the probability is going to be 1/4. Okay. Then we go to this one here. They are saying we list down the possible outcomes if the coin is tossed 3 times. So let us go through it as well. So we are going to begin with our tree, which has 2 branches. Then each of the branches is going to also give other 2 branches, okay, like we have seen at first. Then each of the branches, which have now 4, each of them also generates 2. So lastly, that is what we have. So we are going to still do our movements like we did last time. So we have a head, we have a head, then there is another head here. So what do we finally have? What shall we do for that branch?
head, head, head.
Head, head, head. Then it will be followed by
Head, head, tail. Head, tail, tail.
head, head, tail.
Head,
So we
tail.
still move head, head, then followed by
Tail.
tail. Are we there?
Yes,
Yes,
teacher.
yes.
Now we continue. Now we leave this upper branch. We now come head,
Head,
tail,
tail, head,
head.
head.
head, tail,
tail,
tail.
tail,
Okay. Then we come here, tail,
tail,
head, head.
head,
Then again, tail,
tail,
head,
head, tail,
tail. Then we go here, head, tail,
head,
head. Then lastly we have head, no, tail, tail, and
tail.
Tail, tail, tail.
good. Okay, so I think we have seen, is it hard to generate a sample space using a tree diagram?
No,
Then we shall write our sample space from our tree diagram. So we are saying the sample space is head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and then lastly tail, tail, tail. So I think we proceed. So we go to our second method, which is using a table of outcomes. So like we have seen, if we are, hi, good night. Like we are dealing with the, if we are dealing with the die, so the die has 6 sides. So supposing we are 2 people and each of us is tossing his die, and then we are required to list down our sample space. So the best approach to use would be a table of outcomes. So who can read for us? By show of hand. Precious, can you read for us?
Table of outcomes is used to generate sample space where the sample points appear in pairs of every sample.
Okay, good, thank you. Jessica, read for us our second statement.
Example, 2 ordinary dice, 2 ordinary dice are thrown. List down the possible outcomes, hence find the probability of obtaining a double.
Thank you. So we are going to draw a table. So basically on one side, so we are going to have maybe the first and then the second here. Then the first has numbers 1 up to 6. The second one also has numbers 1 up to 6. Then we begin now pairing, okay? This one can score a 1, and this one also scores. So this becomes 1 pair. Then this becomes 1 and 2. This becomes 1 and 3. And so on until when we get to 1 and 6. Then this one also becomes 2, 1, then 2, 2, until we also get to 2, 6. Then we still do the same, 3, 1 for the rest. 3, 2. Maybe let me add 3, 3 for purposes of demonstrating a double until we get to 3, 6. So we do the same until everything is complete. And then lastly here we shall also have a 6 what? 6, 6. Have we understood that process? If you haven't understood, please, you can either send a message, you can raise your hand, such that we are able to help you out. Yes, Becky?
Teacher, I haven't understood from the beginning.
Okay, thank you. So we said we are using a table of outcomes to generate a sample space where the sample points appear in every pair. So we said, for example, if we throw 2 ordinary dice, so we are throwing them at the same time. So what do we expect? So if for example, we are 2 people and one has a die they are throwing, so there are chances that we are going to throw and all the faces show a 1, 1. So when we are writing those sample points, we write them in pairs, that this has shown a 1, 1, it has shown a 3, 6. So we keep on writing those pairs. Okay, so that is what we are doing. So we are generating, sorry about that, let me share again. We are generating let me first draw some good lines here now. So we are going to have our 1 die, so we can have the first one. So it is numbered 1 up to 6. Is that okay, Becky?
Yes, teacher.
Then we have the second on this side. It is also numbered 1. 1 up to, sorry, 1, 2, 3, 4, 5, 6. So it is also numbered 1 up to 6. So there is a possibility that if both of us throw the die, okay, it is going to show faces 1, 1. So we record it as a pair. Okay, we record it as a pair. There is a possibility that one face is going to show 1 and another face shows a 2. There is a possibility that it will show 1 and 3. There is a possibility that it will show 1 and 4. Yes, Najemba? Any question?
No, teacher.
Okay, thank you. Then there's we can have a 1, 5. We can have a 1, 6. Then we go to the second. If we have, it can show a 2 and the other one shows a 1. It can show a 2 and a 2 as well. It can show a 2 and a 3. So we feed this until when we get to 2 and 6. Then here it can show side 3 and side 1. It can show side 3 and side 2. It can as well show a 3 and a 3. So what I'm saying, we fill this up to the end. Then lastly here, it would be showing a 6 and a 6. Okay. So, but this was for explanation. That I have a complete table which shows all the possible outcomes. I wanted to demonstrate to you how it is obtained. Do we still have any queries?
No, teacher.
Good. So we can proceed. Okay. So that is our table, which is already filled. So I guess now we are able to fill from the start if it is given. So we have all those pairs listed down. So if we are to count them, how many are they? If we are to do the counting,
36.
36. Thank you. So the logic there is simple. Here we have on the row we have 6, column wise we have 6. So 6 times 6 gives us 36. So that would be the total number of the sample space. But then in our question we had that hence we find the probability of obtaining double. Who can identify for us where we have a double? Doubles appearing. Where do we have the doubles appearing?
One, one.
So we have, for example, 1, 1. So each of us can just say one of them.
2, 2,
2,
Okay, we have 2,
3,
2.
3, 4, 4, 5, 5, 6.
6, 6.
Good, 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 good. So those are the ones where we have the doubles appearing. And what is their number if we add them? No, if we count them, how many pairs of doubles do we have?
6.
6.
Yes.
So we have 6. So what would the probability be?
6 out of 36.
6 out of 36. Good. And if we reduce it,
1 out
1
of
out
6.
of 6.
1 out of 6. Good. Any question on this table?
No, teacher.
Okay, can proceed. So that is, those are our doubles. We are listing down now the event. And we are saying the doubles are 6. So the probability of having a double is 6 over 36. And when we reduce it, it gives us 1 out of 6. So we have an example 2. We are saying consider the two sets, A, which has 2, 3, 5, 7, and B, which has 2, 4, 6, 8. We are saying a number is picked at random from set A and is added to a number in set B. List down the possible outcomes and hence find the probability of obtaining an even number. Have we understood the question? Maybe we can read it again. Okay, so we are going to still use the knowledge of a table. So we are going to list our numbers of A on one side like we have done, A on one side, B on the other side, and then we add them up. Okay, because we are saying a number is picked at random from set A and is added to another number in set B. So we're going to pick, for example, if we pick 2, we add it to 2, to 4, to 6, and to 8, and then we get the outcome. So we have numbers of A, they are written in this order. So they are written in this order. So we have 2, we have 3, we have 5, we have 7. Then B is written in this order: 4, 2, 4, 6, and 8. So now we get 2 plus 2. It gives us what? 2 plus 2?
4.
So we write it here. 2 plus 3?
5.
We write it there. 2 plus 5? 2 plus 5?
7.
2 plus 5?
7.
7.
It's there. Then 2 plus 7?
9.
9.
It is also there. So we do the same for the rest. 4 plus 2 is 6.
6.
4 plus 3 is 7. Are we
7.
there? So that is how we generate that table. Any questions on the table?
No.
Good. So now we list down the sample space. So we are going to have 4, 5, 7, 9. So these ones we are going to be writing them 2 times the ones that are appearing, okay? Because each number here matters. So that is our sample space, the one we get after adding these two, after adding A to B. Now, how many are there in total? If we count them, 16. So our number of S, which is our sample space, is 16. Our interest was, what was our interest? We are interested in getting even numbers, okay? We're going to come here to our sample space and choose even numbers. Is 4 an even number?
Yes.
Is 5 an even number?
No.
7?
No.
No.
9?
No.
No.
Then 6?
Yes.
7?
No.
No.
Okay, these don't work. Then we go to 8,
Yes.
and
Then
I
10.
think 10.
Yes.
Number of E is, how many are they?
4.
4.
4. So our probability is going to be 4 out of 16. What do we get when we reduce it?
1 out of
Quarter.
4.
A quarter.
Four.
Yes. Is that hard?
No.
No. Good. Any questions before we proceed?
No.
No teacher.
Okay, good, good. So we go to our third method, which is using permutations. So permutations may seem a bit a new word, but in real life it is not. Okay, we use it every day, only that we don't know that we use it. Now, do we sometimes choose, like if we are going to wear, today I'm going to wear this type of a shoe, this dress, this,
Yes.
do you normally do that?
A lot.
Yeah, a lot. Then the next day you change, okay? So that process is, we call it permutations. You are rearranging, okay? So you are simply rearranging. So with this method, in paper 1, I think later in senior 5, you're going to study about a topic called permutations and combinations. But for me, let me do a simple part here, which is in paper 2. So I'm saying the number of ways of rearranging n number of letters in a word is given by any factorial. This is going to be paper 1 work, but here we are just going to look at formulas, okay? Does any one of us have a calculator?
Yes.
Yes, teacher.
There
Yes,
is you can look for this sign on that calculator. It is in, I think, some calculators pink and some others somehow, some color tending to yellow. That exclamation mark, it is somewhere on your calculator. Have we seen
Yes.
it?
Yes.
Yes, teacher.
Okay, good, good. But in simple terms, when you cover in paper 1, if they say 4 factorial, this simply means that you multiply numbers from 4 until you get to 1. So it will be 4 times 3. Okay, it will be 4 times 3 times 2 times 1. That is what this factorial sign means in mathematics. Okay, so here we should not get worried of it. So our n is going to be like the total number of maybe, if there are letters, if you're interested in the letters, the total number of letters in a word. And then r, we're going to specifically look for those words. For example, if we have mathematics, it has some letters that repeat themselves, okay? That occur more than once. So we are going to be, basically, our work here is going to be simple, just using this formula, n factorial over r factorial. So we can, we have said r is the number of times similar letters are repeated. And n is the number of letters in a word, okay?
Okay.
Then we are going to look at an example. There are some people who haven't spoken and their names are hard to pronounce. Can I request one of them to read for us the example?
Teacher Wanga.
Wanga. Wanga, could you please speak to us and read for us the example?
The letters of word bow are arranged to form different words. What's the probability of choosing at random a word starting with a letter B?
Okay. What is the probability of choosing at random a word that begins with the letter B? Okay. So how many words are in the letter ball? How many words do we have? Hello?
Yes, teacher.
How many
There are
words?
four.
There are 4? Good. So our N is what? N is 4. Do we have letters that are repeated?
L.
How many are they?
2.
Yes.
2. Now, we have the N, we have the R. So I saying, at first we say the number of ways of how we can rearrange those letters is N factorial out of R factorial. So a number of ways of rearranging. So we are going to have 4 factorial. We divide it by 2 factorial. So we said this by definition is 4 times 3 times 2 times 1. Then we divide it by 2 times 1. So I think 2 times 1 will give us a 1. And we remain with 4 times 3.
12.
12.
4 times 3 is 12. So meaning we are going to rearrange those words in how many ways? In 12, the total. Then if we are to fix the B, okay? The B is now going to be fixed because we are going to choose a word where the first letter is what? Is B.
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 So the B is going to be fixed. Are we there?
Yes,
Maybe
teacher.
first go to the
No,
next.
teacher.
No,
Oh,
teacher.
okay.
Teacher, I'm
Okay.
lost.
We said we have this simple formula of rearranging the number of rearranging any number of letters. Okay, so for example, if we have the word ball, it has 4 letters. If we are going to rearrange it to form other words, okay, the number of ways in how we can do that is guided, or we are guided by this formula. So we said N is the total number of letters. For example, we said N is 4. Then we said R is the number of times similar letters appear. So for example, we have L, which is appearing 2 times. So we are saying the number of ways of rearranging these letters is given by 4 factorial, which is the total number of letters in the word ball, divided by 2 factorial, which is the number of times the similar letters are appearing. So the similar letters in this case is L, because it is appearing 2 times. And I've said by definition, the factorial means that we multiply numbers from 4, reducing, so we get 4 times 3 times 2 times 1. That is what the definition of a factorial means. So this is going to be 4 times 3 times 2 times 1. Then for 2 factorial, it's going to be 2 times 1. So the 2 times 1 cancel and give us 1. So we remain with 4 times 3, which we said gives us 12. Are all of us okay up to that point?
Yes, teacher.
Yes, teacher.
Okay. Now, we go back to our question. Our question says, what is the probability of choosing at random a word starting with the letter B? So if we are to write words starting with the letter B, so the letter B becomes fixed. In other words, we are not going to change its position. I think that is where some of us are getting a problem. So the B is going to be fixed. Are we there? And then we change the rest of the 3 letters. So let's move to this next slide. So our sample space is 12. So if we have the word ball, so we are now going to fix B. So these other 3 letters are the ones that are going to be changing. Okay? So in other words, they are going to act as our event. So they are the ones that are going to keep on changing. Am I understood?
A
Yes,
question.
teacher.
Why not A?
Why not A? The logic is simple because we are forming words which are only beginning with B. That is what the question wanted us to do. Maybe if we could. Is it okay?
Yes, teacher.
Okay. So we are beginning with a B because that is what the instruction says. Now, if we begin with the B, now the number of letters is going to change and reduce to 3 because we are now having A, L, and L that we have to play with, that we have to interchange. Okay? Then still our R is going to remain as 2 because we still have these 2 letters which appear 2 times. Then we still get the number of E. So number of this is going to be, number of events is going to be 3 factorial divided by 2 factorial. So this is going to be 3 times 2 times 1. We divide it by 2 times 1. And we remain with a 3. Am I understood?
Yes, teacher.
Yes,
Anyone
teacher.
with a question? Okay, I think then we proceed to probability. So now the number of words starting with the B are going to be 3 words. but then we can form how many? 12 words. So our probability of words beginning with B is going to be our event, which is 3. We divide it by 12. And that is going to give us 1 out of 4. If we reduce by 3, it would be 1, and by 3 it will be 4. Any questions?
No.
Okay. So I think for today we can stop here. We shall be continuing as time progresses. Unless if there is a question.